Hi everyone. Can you just confirm if you are present, guys, in the chat section? Hi Chandrakant. Hi Inder. Hi Vinay. Uh, God, why I'm not able to see the participants here? Oh, there are attendees in the session. I didn't realize. Gallery immersive. Hi everyone. Please confirm your presence. Hi Akshay, Chandrakant, Inder, Sam. Everyone. Oh, hi everyone. I was just, I was like thinking that, I'm the only one in the session that nobody has joined because it was not showing in the view. Why so? Hi Akshay, hi everyone. Please confirm your presence, guys. Are you there? Hi Santosh. I'm really sorry. I didn't realize. I was just thinking that, nobody has joined because I could see only me in this session, unfortunately. Hi Hemant. Beautiful. Okay. Nice. Okay. So guys, thank you so much everyone for joining me in this beautiful uh, you know, uh session. Okay. Thank you so much, guys. Thank you so much. Okay, so in today's session, we're going to start with Apache streaming, everyone. All right. I would like to take the acknowledgement. If you have already gone through any basics or fundamentals of Apache streaming, have you? Basics done, okay. Okay. Basics only, Vinay. Okay. Noted. Basics only. All right. Okay. No problem. No problem. Okay. Okay. So I'm completely okay with that. That's completely fine. Well, okay. Just allow me a minute. I'm going to share my screen with all of you. Do you confirm me if the PDF is visible to you guys? Do you see the PDF? Yes. Yes. Okay. Thank you so much. Um, okay, beautiful, beautiful. Okay. Okay, all good, all good. So, okay, if I ask you this question, like, what is the reason why we are using Apache Spark over MapReduce? What would you reply to me? Let's just warm up the environment here. Well, the primary reason for using Apache Spark over MapReduce. So, and that would be easier to use. Okay, but there is a strong reason there. Efficient and lazy loading is not bad. Automated. No, nobody is replying me the core reason. Core reason. What is the reason? Okay, I'll reply you. So the primary reason, for using Apache Spark or you know, for over MapReduce is in-memory computing, power performance, and stream processing. Guys, do you realize that this is the primary reason, isn't it? Like, come on, everyone, right? So the primary reason for using Apache Spark is that it is way more faster than traditional MapReduce programming. So MapReduce is all about batch processing. MapReduce is a very old and very slow method of processing the data and carrying the analytics process. So that is quite slow, right? And exactly, Inder. That is the point. That is a point, right? Because the whole story of Apache Spark revolves around in-memory computing only. That is the primary reason, for talking about Spark. And then the later, aspects of Spark comes into picture, such as lazy evaluation or DAG or stream processing. So these things comes later, right? This is the later part. All right, TK. Okay, so thank you so much, everyone. So I'm really happy and excited, that we are able to recall all these things. Now, uh, before I start with Spark streaming, I would like to split the streaming concept into. I would like to split the processing into two splits here. So let's call one the first one. Let's call the first one processing or data processing. Let's split data processing into two splits here. One is batch processing and one is stream processing. So these are two types of processing we can think of, What exactly is a batch processing? In batch processing, you have, you know, oh, you are right. You cannot see. You are right in the, okay. I hope it's visible now. I'm sharing the entire screen. Yeah, thank you so much. So we can divide this processing into two categories here. One is batch processing and one is stream processing. Batch processing is all about analyzing or working with archived or historical data, say CSV, TSV, uh, Parquet, and Avro, and let's say JSON, etc. So when you work with data which is historical, which is old, which is stored in the form of a file, that is batch processing. So the technologies which are used in batch processing are like MapReduce. You can use MapReduce here. You can use HBase here. You can use Hive here, right? So all these are basically nothing but tools that can help you to, you know, analyze the data which is stored and which is just dead. There is no motion. There is no behavior. It's just a history, the historical data, right? So you can use MapReduce, HBase, Hive, it'll use a Redshift and similar other tools to analyze your data. Then there comes stream processing. So first of all, what is a stream? What is a stream? Stream is nothing but it's data in motion, right? Data in motion. So any data which is in motion, that is a stream. And carrying analytics on data which is in motion is termed as stream processing. Now, stream processing is done mostly in mission critical scenarios where batch processing tools aren't applicable, right? So I'm repeating once again, stream processing is done mostly in mission critical scenarios where batch processing tools aren't applicable. So let's take an example here. So here's a sample example. Here's an example. Here's an example here. Say there is a nuclear reactor, you know, which is sort of power plant, and there are lots of sensors in this, in this nuclear reactor, which are continuously monitoring the temperature of the reactor. Now, there is certain threshold which should not exceed for temperature. If that threshold exceeds, then there is a good chance that it may cause damage to the reactor, or we can just think of a blast, boom, Oppenheimer, something similar. So imagine sensors sending data to the server, and server is analyzing temperature using MapReduce. Now, do you think that MapReduce will be able to, quickly monitor the temperature sent from sensors, and immediately raise or trigger an alarm? I don't think so that MapReduce is fast enough, to to analyze the data sent from sensors and quickly trigger an alarm if the temperatures are exceeding the specified thresholds. So in this case, if we use tools and technologies like MapReduce or HBase or Hive, then we are going to end up damaging the reactors. So quick analytics is required here, and an appropriate tool, and that is Spark Streaming. Spark Streaming can process the data in real time or in close to real time, where the threshold is approximately less than 10 milliseconds. So in less than 10 milliseconds, you can just, calculate the data, and you can just, trigger an alarm if required. Now, there are a number of other examples also where, there are some other examples which I'm presenting to the participants, where quick processing is required or stream processing is required. The example of Google Maps, for presenting the current traffic, right? So obviously you want your Google Maps to update the traffic immediately as and when it is happening. So if you're crossing by any highway or any street, you should know exactly what is the current status of that street in terms of traffic. So smartphones continuously sending their long details to servers, and and their directions are being mapped, and how close they are, the distance, the difference in the distance defines the traffic intensity. So for that also we need a tool that can quickly process the information and produce the result, and that's where again Spark Streaming is the answer. So these are some of the scenarios and examples which I wanted to share with all of you. That there are instances, there are various number of scenarios. For example, let's say dashboards, right? I'm not sure if you got any chance to work on dashboards, but I remember me managing a Google AdWord, for one of my own websites only, and I was able to do the monitoring in real time, like who are the visitors, from which geographic locations they are accessing the website, and what's their gender, sort of what's the IP address, and for how long they are staying in the website, and currently in which web page they are, or what web page they are viewing. So I was able to monitor everything using Google AdWords. So obviously they must be using a similar technology, or maybe same about just streaming or processing the data in real time. So these are the examples which I wanted to deliver, discuss, convey to all of you to help you understand that how stream processing differs from batch processing. In batch processing, there is no time limit, there is no urgency, there is no threshold, there's no timeout time. But in stream processing, we have urgency, we have severity of time foundations, and we want the data to be processed then and there and produce the results and view the results immediately. So uh, that is what streaming is all about, guys. And another example, last example, which I would like to share with all of you is Netflix or Amazon .in, right? So I'm sure that you must have experienced this when you are browsing through movie, and when you look or select a particular movie, you will realize that Netflix immediately shows you recommendations at the bottom, that the movie that you're viewing, and at the bottom you will see that there are similar movies. Suppose if you're watching Avengers, then at the bottom it will show you a label similar movies, and then it will show you Iron Man, Ant-Man, the Guardian of the Galaxy, and similar. So how it is happening? So as and when you are selecting a movie, the genre of that movie along with your history is sent to the server, and there's this algorithm which is processing your data, and there is some ML algorithm possibly which is generating the recommendation, and that is being delivered to you instantly. The same happens in this Amazon.in also. So when you are browsing through products, so suppose let's say you are looking for a bike accessory, you know then if you're looking for a bike accessory, then if you scroll down to the bottom, it will show you the similar section called similar products, and you will see the accessories which are related to bike. So that basically promotes sales, or that encourages sales. So that has an impact on sales. So this is how streaming helps organizations, companies generate more revenue, provide better user experience, and overall a great customer satisfaction. So along with the profits. So guys, I think I have discussed a lot of examples with all of you where streaming or stream processing is applicable. If you have any questions, you can ask me in the chat section. And if you are clear, please acknowledge you're clear in the chat section. Flume is okay. Thank you, Chandrakant, for asking this question. Chandrakant, if I tell you, right, Flume, I worked with Flume in the year 2016-17, Chandrakant, and the only purpose that Flume could solve was data migration. So I used Flume to migrate log files from one place to another, but I couldn't do analysis using Flume. So the primary purpose, which I believe behind using Flume, is DMT, that is data migration tool. Let me check if Flume is valid today. So this is Apache Flume, and if you observe here, it is a tool that is used for moving, collecting, aggregating, and moving. Now it is not for processing, it's not for analytics. To some extent, you can use it for transformation of the data, restructuring, or you can think of, sort of pivot in Excel or in Pandas, but it is not for processing. It is just for collecting, aggregating, and moving the large amount of log data. It doesn't provide you structure libraries that lets you easily work with structured data, unstructured data, or apply some machine learning algorithms. All these things are available in Apache Spark. For that reason, Flume isn't suggested. Also, I think this is a quite sort of obsolete tools for me. So I suggest you this tool if you want to really work with data migration and better tool for transferring the data from one place to another. So this tool is recommended for distribution of the data instead of Flume. Flume is quite complicated and not easy to use. That's my recommendation. It's completely your choice, Chandrakant. All right, great. Okay, then yeah. So this is just a summary here. Stream processing allows us to process data in real time as they arrive and quickly detect conditions within small time period and from the point of receiving the data. And I missed, giving this example of credit card fraud detection. This is one of the good examples of, in which case a stream processing is required. So that is it. So from where you can get streams of data or the continuous flow of data. So you can just read the text here. I think it's quite a decent text. Continuous flow of data is a ninja technique of identifying a stream. So you can call it continuous flow of data. You can call it data in motion. So that is identified as a stream. So there are several examples which are given here, such as network traffic, sensor data, call center records, or transactions. So these are nothing but a continuous flow of data. The data keeps on coming continuously from all these places. So they are stream of data. So in stream processing, we do not, compute the entire data. In stream processing, we process a window of data, or you can simply call it, if you are familiar with this, moving average in SQL. So this is a very good example of, of a segment of data, or you can say a section of data, which is computed, in a part manner, or if you recall partitioning in SQL, then this is another example of how the data is processed in small blocks, small sections, small windows. So that small partitions, small blocks, which are being processed at a time, those are called windows here, and they are processed in less than a second, and each block processing is independent of the any other block which is about to come or which is processed already. So each block of code is independent. Now here it is. So in this slide, you can see that from what are the various sources through which you can read the data in Spark, and where you can push the data into after the data is processed using Spark streaming. So when you are using Spark streaming, which is the extension of your Spark API, you can take the input of data from Apache Kafka, which is your message queuing system. Then we have Apache Flume, which is your tool, which we just read, right? A tool that is for collecting, aggregating, and moving the data. Then we have HDFS. HDFS is basically a distributed computing storage layer where the data is just stored as a file. And we have ZeroMQ also. This is again another message queuing service. And the last example is Twitter, which is, I think it's obsolete now. This has been renamed to X. So you can just subscribe to a developer account of Twitter, and you can just read the data directly from Twitter tweets as a stream. Then after collecting the data from all these sources, you can simply process it to carry analytics, and you can just redirect the output or store the output into HDFS or maybe some databases such as MySQL or maybe MongoDB, or you may just redirect to some dashboards also. So you can just push it to ClickView or Tableau, or you can just use Matplotlib or Seaborn if you wish to visualize the data. So the summary of this slide is that you have a lot of input sources available for Spark streaming, and you can just redirect the output to various other destinations here. Okay, then there is this term called D streams that you will learn in your grad videos also. D streams are called discretized streams or D streams. So what is a D stream basically? Discretized stream is, you can think of it like a data structure. Okay, let's simplify this term. I think if in case you're learning this for the very first time, you may find it inconvenient. So let's simplify this. You remember that NumPy has its own data structure to process the data. You remember the name of that data structure? What is the data structure that NumPy uses? Exactly. So ND-array is an abstraction provided by NumPy. Can we say this? ND-array is a data abstraction provided by NumPy. Can we say this? ND-array is a data abstraction provided by NumPy. Let's take one more example. What is the data structure that is provided by pandas for storing and processing the data? Is it list, double, set, dictionary on ND-array? No, exactly, Chandrakant. You're absolutely right here. So the data structure which is provided by pandas, to process the data are series and data frame. Remember, one is series and one is data frame. So what is series and data frame? Series and data frame is nothing but an abstraction provided by pandas for storing and processing the data. So the summary that I want you to collect from these examples is that every tool and technology provides its own data structure for representing data. NumPy provides ND-array, Pandas provides series and data frame, and Python provides list and tuples. Similarly, Spark provides RDDs. Remember, Spark provides RDDs, and Spark streaming provides discretized stream. Discretized stream is nothing but the data structure which stores the data in parts here, in segments here. So discretized stream is nothing but the collection of data in a timeline manner. So this is the data from time 0 to time 1, time 1 to time 2, time 2 to 3, and time 3 to 4. Right? So these are small windows, you can say, right? So for example, if I simplify this, this way, let's say from 09 to 010, this is the first window, which is carrying all the transactions. And then from 010 to from 011 to 10 to, sorry, 10 to let's call it 59. From 10 to 10:59, there's a second window, and from 11 to 11:59, third window, and so on. So these are basically time-based windows here. 59, like this way. So we have time-based windows here, right? So this has the transactions from this one to this time. This has transaction from this one this time, and but in actual environment, it will be very, very small time window. It will be around 09 to, let's say, 09 15 maybe, or 0901, sorry, a window of 1 minute, let's say. I think it should be lesser than that also, right? It could be 30 seconds, right? It could be 15 seconds also, it could be 10 seconds also, depends upon, what is the severity of your task, what is the severity, right? For example, NFT, right? In NFT, guys, what is the timeline? What is the time limit for getting the amount transfer? You remember? In NFT, approximately. So when you do NFT, how much time it takes to get it credited? No idea. Oh, it's actually 30 minutes. So can we say that the data is processed in a window of 30 minutes? That's a बोल सकते हैं, guys? Are you getting it? So all the data which is collected in the 30 minutes span is processed at once. So this is called one window of 30 minutes. Are you getting, guys? What is window representing here? आपको समझ में आ रहा है, guys? What window is representing here? For the data collected in the span of 30 minutes. Here. If you have any questions, please feel free to ask. If there are no questions, please reply with no Q, or you can simply say clear in the chat section if there are no questions. Okay, thank you so much. Okay, thank you so much. Now, can I ask you, right, have you gone through the basic practicals of Apache Spark, like the Spark RDDs? Have you done practicals on like creating RDDs using SC.txt file or SC.parallelize, then the map, flat map, the actions and transformations. Have you done all these practicals already? Okay, Chandrika, noted. Noted. Okay, Dwyer, fine. Thank you so much. Okay, okay, okay. ठीक है, no problem. We'll do the practicals. Um, can I ask all of you guys if you have any environment available for doing Spark streaming practicals with at your end? Do you have the environment available? Or in the noted, Chandrakant noted. Okay, so if in case if you're willing to follow with the practicals parallelly, I would like to encourage all the participants here for that. So please confirm everyone. If you wish to participate in practicals parallelly, please reply with +1 in the chat section. All right, so no problem. Okay, Hemant, noted. I have Spark local, but most of the others might have to rely on the clusters. Yeah, Chandrakant, in order to fix that, I am going to provide a small coffee break here first, Chandrakant. So the strategy is basically I'm going to provide all of you with a small coffee break. And in this coffee break, I'm expecting participants to prepare the setup. And post break, I'll be assuming that you're ready with the cluster, and we can then begin with the practicals parallelly. So this way, we'll be saving some time on the practicals, on the preparation part. So guys, can I assume that if you're willing to do the practicals, you will be preparing the setup in this break? All right. All right, guys. Okay. Sure, guys. So let's go for a small coffee break and then we'll resume. All right, guys, welcome back after the break. Um, Please confirm your presence by replying +1. Everyone, are you there? Thank you, Chandrakant. Please confirm your presence, everyone. Thank you, Inder. Thank you, Hemant. Thank you, Akshay. Thank you, Rupali. Thank you, Amrita. Okay, so guys, if there is anyone who is willing to do practicals parallelly, please reply with ready in the chat section. If you're ready with your cluster. All right, Chandrakant, noted. Okay, just allow me a minute. I'm sharing the screen with all of you. Mm. Mm. Guys, connecting to the EC2 instance. Setting the inbound rules. So my IP address is already added, so no need to do this step. Switch back to EC2 instance. Now I'm going to connect to my server. So I'm logged into my instance right now. And here I'm going to launch Jupyter Notebook. So this is running now, colon, accessing the notebook. And you can see that I'm able to access the notebook here. Now I'm going to create a new notebook here. And let's give it a name, demo, Spark Streaming. Okay, so if you have any questions till here, you can ask me, guys. And if you think you are clear till here, just acknowledge with clear in the chat section. Guys, if you're clear, just acknowledge with clear. And okay, thank you so much. Okay. Now we will do the necessary environment setup here. So because I'm using Jupyter, I need to configure the environment variables. So I'm writing the codes here, drive, and I'll be sharing the codes with all of you in the Google Doc as well. So whatever demonstrations I'm doing, I'll be sharing here in this document. And this is going to be with you. You can just open that document. And I'll be sharing all the codes in that document with all of you guys. Just give me a moment. Okay, so here are some environment settings which I'm doing. So in this environment setting, I have shared this environment variables here. So in this settings, I'm basically, setting this Python SpicePark Python driver. Then we have this Java Home, Spark Home, PySpark driver, Python libraries, and PySpark libraries. So these are some of the environment settings that we have done so that whenever we are executing the code, so we are able to, identify the commands, the classes, uh, and the keywords that we are using. After this, we will be Chandrakant, if you want Kafka configuration, I can do that if you want. But that will be, that's going to take a lot of, okay. Kafka is good. Kafka is also used for streaming here. Okay. Then the next step is to create the Spark context. So I'm sharing this here in this document as well. This one. So here we created the Spark context here, which is Spark version 2.4.4. My master, that is my server is localhost, and the application name is PySpark shell. Yeah, sure, Inder. I'll just share the link. It's here in the chat. Okay, I hope you're able to access the document now. Then once we have created the Spark context, the next step is I'm going to show you a data file here, which I'll be using as an input file, which is cat rime.txt. So this is basically an input file here. This is input file. Oh, I missed. Oh, that is why the participants were not able to access it, is it? I was sharing it with only host and panelist. So now I have shared this with everyone here. Okay. Great. So if I use kernel here, see, if you observe here, Vinay, I don't have that kernel available with me. So that for that reason, I had to set the environment variable. You are also right that if the kernel is configured, then we just need to set the kernel. That will be the shortest and quickest way. Oh, okay, noted. So this is the input file, which I'm using here as my uh, input file. And now I'm going to read this file. Like I'm going to read this file using text file method, and I'm going to create an RAD out of it. So here you can see I'm using rhyme.txt, and the method that I'm using here for reading the text file is spark context object.text file, and this is going to use I'm going to use this method for creating the RAD here, and the name of the file is in rhyme.txt, and this returns me an RAD here, which is word RAD, and if I show you the type here, it is PySpark RAD, and if you look at the raw output, this is the raw output here. Okay, so this way we are able to create an RAD here. And now we're going to work on this RAD to extract some insights and facts. So just give me a moment. The next step is to display the content of the RAD here. So let us display the content of RAD by calling word RAD dot collect, and this shows you the data in a similar list-like fashion. So I'm going to share the screenshot quickly here so that you can quickly get a understanding that exactly how it looks like practically. Okay, so here I'm using this collect method here to see what is the content of this file, and now we'll be splitting the content of this file using the split method. To split the content, we'll be writing map of flat map action here. So let's use map here. Let us use map to split each element and create a new RDD. So to do this, I'll be writing RDD0 equals to word RDD dot map lambda line dot split by space and small and RDD0. So here is the content of RDD0, RDD0 dot collect. Now, if I ask you, right, what dimension does it looks like to you, right? What kind of, how many dimensions are there in this data? Anyone? In RDD0. Two dimensions are there, exactly. That is absolutely right here, Chandrakant. It is a two-dimensional data. It's a nested data, basically. Now, this is an interview question, basically, like what is the difference in map and flat map? And by looking at the output, will you be able to explain the difference in map versus flat map. So it's an interview question as well. I'm sharing the screenshot in the doc as well. Here. That is right, Chandrakant. That is absolutely right. So it converts the multidimensional data into single dimension. That's right. So that is absolutely right here. So flat map basically converts this 2D data by default, which is of map response, into 1D. You can see the response at line number 18. And okay, just a fun activity here. So which method of NumPy we can compare flat map with? Anyone? Just a revision recall. To which method of NumPy we can compare flat map with? Anyone? Exactly, Dorpa and Sarkar. Thank you so much. This is a beautiful response, and this shows good memories and good practice also, sort of. Yes, flatten. Flatten is similar to, flat map in Spark. Okay. So once we have converted this data into, list of words here. Now the next step is to, okay. So I forgot to mention the objective here, which is to find the frequency of each word. So this is the objective that we are, fulfilling in this lab, or you can simply call it word count. So this is the objective we are fulfilling. RED0.collect. So this is the data here with us. The next step is to transform linear data into key value pairs, where each key will be word and value will be 1. So how exactly we're going to do this? We're going to do this way. RDD is 1 equals to RD0.map lambda word colon word comma 1. So we should see, key value pairs as a tuple. So RDD1.collect. And guys, just have a look at it and let me know if you are clear with this step. I've shared the screenshot in the document as well. Please confirm if this step is clear to the participants. Make sure that you're keeping the objective in the mind. What is the objective? That is word count. If you have any questions, you can ask me. If you are clear, please acknowledge with clear. All right, shall I proceed further if there are no questions? Okay, thank you so much. The next method is the next step is to use reduce by key method to aggregate data, that is finding sum. To do this, we'll write RDD2 equals to RDD1 dot reduce by key lambda a comma b colon a plus b and RDD2 dot collect. So this reduce is works exactly same way as it works in Python. So if you recall, if you're able to recall the functioning of reduce in basic Python programming, then you will be able to, understand how this code is working. If in case, if you think that you're not able to understand this code, you can just ask me. So I'll be more than happy to explain it. And here is the code that provides you the word and their frequency. This is end of basic thing. Okay, so if you have any questions, please ask. If you're clear, please acknowledge it clear. And what you're seeing here is the word and its frequency. You can apply do the same in Python API. We can apply it directly on argument, right? We cannot Chandrakant because the iterable, the iterator which which returns the data, it will not be the way it is expecting, Chandrakant. For that reason, we cannot use it. To show you the bigger picture here, everyone, I'm going to show you one more demonstration here, which is on log data analysis. And here is the data set which I'm sharing with the participants. Access log. So if in case if you're willing to do practicals, you can just prepare this data set. It's a compressed data set. You need to decompress it, and I'm also sharing the same here. How to copy text file without SSH unable to access it by importing to Jupyter, as we do in our local machines. So first of all, you should be able to upload in the right. If you're unable to upload it, simply do one thing, right? Step one, create bucket in S3 and upload the file there with public access. Step two, copy the object URL of the file. Step three, using wget command in EC2 or EMR instance, download the file using the below syntax. Wget object URL. And if you do this, you will be able to, see the file. Step 4, use ls command to verify. if file is downloaded. In the this is how exactly you can do it without SCP or SSH or without upload. I hope this helps. Okay, thank you so much. So the next demonstration that we're doing here is on access log. And what you're seeing here is basically, the data of clients who were accessing the web server. So whenever there is any client who is accessing server, what server does basically, it stores the information about the incoming request. So what information is being stored here? So you can see the IP address of the client, date and time when the request was sent to the server. This is something called HTTP method, get in post. This is the protocol version, and this is the HTTP error code, and this is the file size. So this is nothing but the access log. This log is maintained whenever a client sends request to server. Now, what is the objective here? What is the objective? Objective is to analyze this log data using Spark streaming. So how do we do this? Sure, Devrata, I'll just copy and paste it. Okay, just give me a moment. Yeah. Okay. So guys, do you confirm me if you are comfortable with the context of what this log data is all about? Are you comfortable with the context? There is no constraint of data when working with logs, right? Not exactly. There's no constraint here, Arjunakant. The data, any type of data can be worked upon. So here, primarily at this level of tools and technologies, we are mostly into this, whether it is structured data or semi-structured data. So it is semi-structured. So yes, we can work with it, irrespective of what data type it is. We can. Let us create RDD of above data. RDD 0 equals to sc.text file access log, capital, and so let us find the count of records in the RDD. For that, I'm going to use the count method here. RDD 0 dot count. So because it is a quite huge data, right? So it is going to take some time to find the count, and the count is available now. So there are 4 million plus records available. So there are 4 million plus records in this data, which is quite huge. And we're going to carry analysis on this data. So let us check the preview. Let us see the preview of the data. So this is going to be rd0.take and 5. So what you're seeing here is the first 5 records of your RD, and there's just a preview. Please make note that you should not be displaying all the data using collect, because your server may freeze It's a huge log data, and you definitely would not like to wait for long. For that reason, avoid using collect on such data and use take method. So quick question here, to which method of pandas take uh, matches or resembles with? Anyone? Oh, this is not this much difficult. Yes, the answer is quite correct. It is head. Head and take both match. All right, so let's proceed further. Okay, let us learn the filter operation on RDD using filter method. Objective is to extract only logs where IP matches with 10.223.157.186. So this is the objective that I'm. No, I have decompressed it already. Using gzip command. Okay. Now we are going to, you perform the filter operation on this RDD. So it's going to look like this. Okay. Suspicious logs equals to RDD 0 dot filter lambda line colon 10.223.157.186 in line. So here I'm using this membership operator here to check the presence of this IP address in each line. So whenever if any line contains this IP address, that will be returned as a result in suspicious logs. So it's done now. Let us find how many. Let us see the content. See the content first. So suspicious logs.take 10. And did you observe that all the logs are exactly same? It's the same IP address. Just a second, guys. I missed providing the screenshot actually. So I'll just update the document. Done. Okay. So are you able to realize that this is we are seeing only those records which are, which we filtered in the condition there, like 10.223.157.186. Now let us find how many such logs are there. So that would be suspicious logs dot count, and so there are in total 115 logs are there with the given path with the given IP address. If you have any questions, guys, please can ask. All right. If you have any doubts, please ask. And if you are clear, please acknowledge with clear. All right, Mr. All right, waiting for a few more responses. Thank you, Akshay. All right, guys, if there is any doubt, please ask me, guys. All right, so I think we can proceed further now. The next step that we are doing here is to find the IP addresses. Objective, find the top 5 IP addresses sending most requests to server. The idea here is to find abnormal users or clients. To find the top 5 IP addresses sending most requests to the server, what we'll do first, we will extract IP address from the data. First, we will extract only the IP addresses and create a new RDD. So that would be RDD3, RDD0 dot map lambda line colon line dot split by space and 0. So if you look at RDD3 dot take, you will realize that we just have IP addresses only. Because what I've done, I'll show you here. The logic which I've followed is, so we have this IP address, and we are splitting it by space, and then we are choosing the first element after splitting. That will be IP address. See, this is the logic I'm following. Please observe. I'll provide you the screenshot also, so that it's easy for you to understand. So here is the IP address, and here is the logic. Yeah. Sorry. Do you confirm me, guys, if the logic is clear to you, how we extracted the IP address? All right. All right. Okay. Can I get some more confirmations? Yeah. Thank you, Chandrakant. Thank you, Akshay. Now we have find the count of IP addresses. So we should have same 4 million IP addresses with us. And the count is same. The next step is to generate key value pairs, where key will be IP address and value will be 1. For that, we'll be using map method again. rd4 equals to rd3 dot map lambda IP colon IP comma 1 and rd4 dot take 10. You can see here we have just transformed our data from linear to a key value pair structure. So you can call it a list of tuples where each tuple contains key and value. Key is the IP address and value is the 1. Now, can you guess exactly, like if I want to do the aggregate on this data and find the sum of values for each unique key, which method I'm going to use here? Anyone? Reduce. Reduce by key. That's right. Absolutely right here. Absolutely right. That's right. So it is not just reduce, but reduce by key. Reduce works on linear data. When you have linear data with you, then you will use reduce. But when there is a key value-based data, then you will use reduce by key. So using reduce by key to find the sum of values for each key given. So to do this, I'm going to say rdd5 equals to rdd4 dot reduce by key lambda a comma b colon a plus b rdd5 dot take 10. So it's taking a lot of time. It's lazy evaluation. So we have the numbers here. We have the IP and its frequency. So what you are seeing here is the IP address and its frequency. Now, if I want to find the IP addresses which are sending the most request, what is the logic or algorithm I need to follow? Anyone? If I want to find the IP addresses sending the most request, what is the next step? What should be the next step? Anyone? Sort by value in the absolutely correct. Okay. Yes, there is no need to put question mark on your statement. You are absolutely right here. Yes. Yeah, but that will be ascending order, Chandrakant, isn't it? Because the behavior is ascending, and I really, really appreciate that you have a very good sense of programming here. So that is nice. You are absolutely correct. Guys, just give me 2 minutes. I'll be back. All right. There's something important. I'll be back in 2 minutes. Hi, everyone. Apologies for the gap here. Please confirm your presence, guys. Are you there? Thank you, Inder. Okay, so let us sort the data by value in descending order. To do this, we will write sorted IP equals to RD 5 dot sort by lambda tuple 1 ascending false. Top 5 equals to sorted IP dot take 5. Top 5. Do you confirm me, guys, if the sorting and extracting the top 5 users of server is clear to you guys? This approach? Okay, thank you, Chandrakant. Okay, thank you, Indra. Now, thank you, Brita. Spark Streaming provides Spark Streaming structured API also to query or analyze structured data. In the next step, you will see me creating a data frame, Spark data frame out of this data. So the next objective is to, next step is to create a Spark data frame. No pandas one. To store structured data. To do this, I'm going to import the required libraries here from PySpark.sql, import SQL context. SQL PySpark. And then pf equals to SQL context dot create data frame. Top 5 schema will be IP string request count integer. SQL context QL capital. Come on. Data equals to. Is wrong. Top 5. Wait. Data. Oh, wait. I missed creating the object here. SQL object. SQL context equals to SQL context. We're going to create the object of this class. So I'm going to create here. Pass this Spark context object here. And here we'll use the object of SQL context. And here is the data frame. Okay, so this is a Spark data frame, guys, and it's not a Pandas data frame, right? So the only reason to show you this demonstration is to tell you that Spark Streaming provides Spark Streaming structured API also that lets you query your data just like the way you query data in Pandas. Later, you can decide, you can also decide to export this data into pandas as well. So if you want to do this, it would be like pandas data frame equals tf.to pandas. Pandas data frame. And here it is. So the first one that you see here is your Spark data frame, and the second one you're seeing here is just the regular pandas data frame. You can also use data visualization here to plot the data. That is the schema structure, right? The column structures, Chandrakant. IP, first column will be IP address and it will be string type. Second column will be, the label of second column will be request count and that data type is integer. That's the schema, Chandrakant. Column name, data type, column name, data type, column name, data type, column name, data type. Okay. Now, if you want to visualize it, you can also visualize it. And so import cborn as a sentence. That's a joint plot. It will be x equals to IP, y equals to request count, data equals to pandas data frame, and we are done. So do you see the IP address which is having the highest frequency in this plot, guys? It's something like 110.216.13, something. So guys, are you able to realize the journey from loading the log data to visualizing the log data? Are you able to get a good understanding of this journey, from loading log data to visualizing it? For your convenience, I'm going to share this notebook with all of you as well. So just allow me a minute, my drive and jQuery CDN. File upload. That is the wrong one. Downloads demos stream. Okay, and there it is. Share and copy. So all labs here. Okay, I'm sharing the link in the document as well. All labs here. All right, we are done, guys. So that is it, guys, for today's session, everyone. And I'm hoping that you enjoyed it. I'm hoping you liked it. And I'm hoping that we are leaving the session with lots of, understanding and confidence about, how to work with Apache Spark. So with this, I'll take a leave now, guys, and I wish you all the best and a very happy holiday to all of you.